MEG has always been a highly interdisciplinary field, attracting engineers, physicists, physicians, medical physicians, psychologists, and cognitive scientists. The, the, the pioneer of MEG and the father of MEG is David Cohen at MIT, and he was a physicist. So I've long been used to talking to engineers in my work with MEG. There can be an initial period where each of us has to establish a common vocabulary because we talk about different things. Engineers initially really don't know anything about anything that contains the word mental. That really doesn't make sense to an engineer initially. But it's very important to us as cognitive scientists because we study mental processes. But I think where you see that very different disciplines like engineering and cognitive science becoming interested in similar problems, okay? Similar problems in this case, like how does the brain interpret signals from the cochlear implant? I think these are areas where you can really be assured that some very interesting and exciting things are going to happen in science. And this is certainly the case in the field of cochlear implants. Whereas I've indicated before, the engineers are necessarily becoming very interested in high-level activities in the brain. They don't just consider the implant itself anymore and the low levels of the auditory system, but they have to consider how the brain itself adapts to and interprets these signals from the cochlear implant. And people like me are necessarily, as a consequence, becoming interested in the engineering details of cochlear implants. And I spend more time than I like to think of hearing lectures from engineers about, very low-level details of the circuitry of cochlear implants.